Alright, hello guys. Mr. Hudson here. We are going to start today by talking about literal equations. Hopefully you found the 1-4 notes in Schoology there in the Chapter 1 folder. But a literal equation is an equation that contains two or more. Bear with me as I get used to the ink pad. Variables. And actually there should be an S right in here. It is often helpful if we isolate or, and you probably know it, solve for. When we isolate a variable, we're often solving for what that value is. So when we come down here and we look at equations like this, and you may have seen it if you've worked through the Pearson module at all, this is the got it question from 1-4. So it says solve the equation, as you see there, for m. What are the values of m when n is those three values? So I always start by writing my equation out somewhere. So we have 4 equals 2m minus 5n. And since we're wanting to get m by itself, I always look at, okay, it's positive. So I'll just get rid of the other term, and we can do that by adding 5n to both sides. So now I get that 2m by itself is equal to 4 plus 5n. And in order to get rid of this 2 and isolate the m, we want to, hopefully you said divide. And it happens to everything on that side. So 4 divides by 2, which gives me 2. And 5 divides by 2, which we can either say is 5 halves, or you could say is 2.5. And that is now our value for m. And it is the independent variable, or it is the dependent variable. It depends on n, which is independent. So now we plug in these values for n. So we can now say m is equal to 2 plus 5 halves times negative 2. And what's nice about this is if we set up negative 2 over 1, the 2's on top and bottom cancel each other. They leave just the negative. So we have m is equal to 2. The negative now took over with the 5. So it's 2 minus 5. And this one value for the m, 2 minus 5, is in fact negative 3. So if you have not yet, take a moment, pause the video, and try to solve for the other two values of m, where n is 0 and 2. Alright, hopefully you wrote out equations that look like this, and when we set that up and then we solve, well, we know that anything times 0 is, that's right, 0. So now we get a value of m equals 2, and over here we have m equals 2, plus, again, the 2's on top and bottom cancel each other out to make a 1. So we get 2 plus 5, and our third value for m is 7. Take a moment, try to solve b. B will not make sense unless you've looked at the Pearson module and worked through some of that, but give it a shot. Alright, so b asks us to sub in for x and then solve for y. So if we do that and just copy down the equation just subbing in for x, 10 times 3, we get 30, 5y equals 80. Then to isolate the term with y, we want to get rid of the 30, so we would subtract. We always do everything on both sides. Sorry about how that looks. We have 5y equals, well, 80 minus 30 equals 50, which leads us to y equaling 10. And then we can do the same thing over here when y equals 6, and we can say 10 times 6 plus 5y equals 80. So we have 60 plus 5y equals 80. Again, to get rid of the 60, we're going to subtract that from both sides. Now we get 5y is equal to 20. And then by division on both sides, we would get that y is equal to 4. So there are our two values for y. Now, whether or not you prefer that method, Really just depends on what kind of brain you have, whether you like getting the value of the variable first and then plugging in, or whether you'd rather plug in and then isolate the variable. And really that's all up to you. Makes no difference. Alright, take a moment and pause the video and try to solve number 1 or number 2 if you can. Yeah, now's your chance because I'm going to dive right into them. So when we have x as our independent variable and we have values for x, we want to start by isolating for the variable or plugging in. I like the method where we isolate for the variable first, since I'm going to need to plug in 3 different values. So I start by getting rid of the x and really trying to get the y as a positive y to figure out what y is equal to. So I will subtract the x, and that looks like a y. And I get negative 4y is equal to negative 4 minus x. And then because this negative 4 is held together with multiplication to the y, I need to divide, and I'm going to divide by negative 4 to have that carry through and get rid of the negative on this side as well. And now we will get that y is equal to, well, negative 4 divided by negative 4 just gives me 1, and a negative x divided by negative 4 gives me a positive 1/4 x. So then I'm able to use the, Alright, we got the page back here. So when you set up equations to plug in for those values of x, we've got our negative 2, our 4, and our 6 plugged in. So that gives us 1 plus, well, 1/4 of a negative 2. If I think of this as negative 2 over 1, it's really a negative 2 over 4, which makes this negative 1/2, which can really be thought of as 1 minus a half instead of plus a negative, which gives us 1/2. Sorry, that is an equal sign, not inequalities yet. If we have a 4 here, we can think of that as 4 over 1, and then these cross cancel, the 4 on top and bottom, so that gives us a y value of just 1. And then we have a 6 on top, that's like 6 over 1, so we can say it's 1 plus 6 over 4, and 6 over 4 can be reduced to 1 plus 3 over 2, which is really like 2.5 once I combine everything. If you didn't pause and try 1, pause and try 2 now. Alright, I've given us a bit more space here on our page. So we have 6x is equal to 7 minus 4y, and we're going to be plugging in for x. Let's go ahead and take the other method and try plugging in and then solving. And actually I may show both here. So if we have 6 and we plug in a negative 2 equals 7 minus 4y, well, negative 2 then makes that combine to be a negative 12 equals 7 minus 4y. To get rid of this positive 7, we could subtract. And when we subtract 7, we get negative 19 equals a negative 4y. And that is not very fun. So I would divide by negative 4 on both sides. I'm kind of out of space here. But you'd get negative 19 over negative 4, which the negatives can cancel out, and you can get 19 over 4, which is just shy of 5. So it'd be 4 and 3/4. Alright, so then if we do that again, but we take 6 times a negative 1 equal to 7 minus 4y. Sorry, my pad's being kind of weird. We get negative 6 equals 7 minus 4y. We can subtract 7 from both sides. We get a negative 13 equals negative 4y. From there, we would divide negative 4 from both sides. We get y equals negative 13 over negative 4. Negatives cancel out, and you get negative 3 and 1/4. And just for the fun of it, now I set it up isolated for the y, so y equals negative 6/4 x. We could reduce that to negative 3/2 x plus 7/4, but since all we have left to do is the 0, when I plug 0 in there for my x, it makes that 0. We get y is 7/4, and that as a mixed number is just 1 3/4. Alright, so moving on to problem 2, where we're trying to rewrite a literal equation with only variables and no numbers involved. So what we are trying to attack first is solving for x here. Now x is in a term being multiplied by another value. So the thing to always keep in mind is that we want to get that term isolated first and then deal with isolating x, actually isolating the variable. So isolate the term, then isolate the variable. So what we need to do is remove the r first. So if we write out our original equation, negative t equals r plus px, and then we want to get rid of the r, we can just subtract it from both sides. Because we don't know if these are like terms, we can just say negative t minus r equals p times x, because these canceled. So now my x term is isolated, and I still just need to isolate for the variable. Since these are multiplied, our inverse operation is to divide by p on both sides. And then I always like to write what I was solving for first. So now we have x is equal to negative t minus r all over